Perfect. Yeah, I think now, now it seems to work. Yeah. So Zoltan, about your question, how to formally organize this. We had, I believe, two meetings across which this straddled. We had some interim results that people were able to report at a physical IEA Annex 82 meeting, and then feedback was provided, and people were, specifically asking, does that sound good? Am I on the right track? I think, given our somewhat more expedited timetable, that we would do in our monthly meetings, like the one we have right now. So I would say nothing formal. People were well instructed. They knew what to do. They had used different tools, and I think we have a fairly comprehensive set of instructions. And I think those who have the intent to participate, I think through the Slack channel, we have an opportunity to clarify questions and help each other out. I think now it's a matter of getting started and using the time that we have until April. We can think about the prizes, make the carrot a little bigger.
Alfonso is providing wine. No, just kidding.
Yes. I'm working on that.
Okay, well, let me ask. So those who were not, because I know Sabrina and Catherine and Eva,
Sabrina has a question. I think Sabrina just raised her
Sabrina
hand.
said a question, or is it from before, just a hands up?
No, I think it was for before.
Okay.
Sorry.
Okay.
Very good. So are there people in the room who started that were not initially familiar with the setup and everything? Annalise, I think you started from scratch, and Mina, I think you also. Do you have any thoughts on getting started? Is it too hard? Do you need feedback, or is it going well?
So I was helping the group with the initial documentation setup after making sure that people who were starting from scratch could start from scratch. Here, I'm realizing my camera isn't on. Sorry. It's going pretty well so far. I haven't done anything with making my own controller yet to change any of that, but I got the example to work and the data matches. What I found is that there are some interesting things going on with Python and compatibility, because apparently the newest kernel update for pip doesn't work with the current stuff. But I made a note of that, let them know, and I think they probably put it into the documentation. And yeah, otherwise I think it's going pretty good. The other note that I would have is that I wasn't sure how to change the time steps, but I know we had discussed putting that into the documentation as well. So
Cool. Okay. That's positive.
And more or less for me the same. Unfortunately, I didn't have enough time during the last months that I work, and same as her, I didn't apply my controller yet. So I just tried to work with what Ava explained us in the last meeting. So far, I didn't have any problem, but I will share with you if I have any update or question.
Okay. I think we just want to make sure that, you all come and work. Ava?
May I request something?
Sure. Well, we'll see about the request. Let's see.
No, I just want to have all of those feedbacks and probably in our Slack channel so we can track them, because we have some feedback from analysts. We worked on that, but because it was for our previous notebook, it's better to have them, like if more people are involving, if we could have those feedbacks within the Slack so we can track them, and anyone that can help with that would be more efficient in my view. But still, an email will also work. But if we can have those written somewhere that this is the problem, can someone look into that, and then we can quickly make the changes and everything. That's my request.
So I have a question for those who are working on the common exercise. Did you analyze the demand energy profile of building that we have selected for the cluster to analyze and the energy generated by PV? But my question is related to the fact that what we are now realizing together with Sabrina is that in some cases, Zoltan, Gregor, the PV panels seems to be too much. So the PV plant is oversized for some building.
PV is oversized. It used
oversized.
to be undersized, right?
Oversized.
Yeah.
And so we have a lot of energy that exported to the grid. This appears from a first, analysis of the results from the algorithm that is,
there's two ways, two things. I think Eva mentioned it to me also. One is obviously in this common exercise, we don't really care about the export because we're not putting a value on it, right? So it's kind of like just lost energy in that sense. If it bothers, I think it's in the Texas case, right? Not in the Vermont case where there's too much solar. If it bothers, we could size the panel smaller. We can adapt the data set. That's not really a problem. Right?
I'm not sure that it is not a problem if we want to track a reference load profile that is related to net electricity demand. Because
no, go ahead.
If in the RBC mode, we have a lot of energy produced by PV that is not used by the building, that is exported, then this affects the construction of the reference profile that then we want to track with the advanced control.
Well, yeah, but if you clip it at 0, then it doesn't exist, right?
Yeah.
So it's not impacting your net load. It's just 0. You don't get negative load at that time. No?
Yes.
If anything, a lot of solar will make the problem very easy, because you can start.
I think that's so. I'm taking a look to the algorithm that is at the base of the panel sizing. So it is not too much clear to me how the number of panels are then calculated. That's the reason why we are trying to implement a new or a different procedure to evaluate according to the net floor area, the number of panels.
Yeah. I don't remember. We tried different ways, but I don't think it's a problem to change the number. Like it's not.
Yeah, we can do it.
It's not relevant. Yeah. And I think that holds for everybody. If you find something like this, or some of the metrics are not clear, or you come up with a new metrics or that you implement, you can share so that people can use it. Indeed, and then we update. We can easily update the data set, and then everybody can work with that data set again. I think that's cool.
Yeah, but I believe you agree that a change to the configuration of the homes should be then a change that all of the participants utilize. Okay.
Yeah. It should be pushed centrally, and then we just tell everybody to re-download, and then it should be good. That's the advantage of doing it this way. Cool. Eva, you had a heads up?
Yeah, I just wanted to mention that we changed the nominal power of the PVs because from the previous version, it was so little, like it wasn't realistic for Texas. Me and Sabrina and Catherine discussed this, and then we decided maybe it's better to multiply that. So we have some sort of PVs realistic for Texas, but I agree that right now it's too much, and just we need to change that multiplier. It's not a very difficult, but we have to discuss this with the whole team to come up with a realistic number for the nominal power. But I just wanted to mention that we changed that, and now it's too much. Like previously, there was no PV generation, which was not realistic for Texas during summer. But right now, I discussed this with Zoltan yesterday that this is, I think it's too much.
Can I ask how much we currently have, Ava? What is it? What in Texas? What are typical installed PV capacities that you have that you've determined now for those 25 homes?
Just multiplied, I guess, with 10. I think Sabrina can.
10 kilowatts? 10 kilowatts DC, is that it?
Yeah, right now it's Sabrina can.
It's the PV nominal power is 10 fixed for every building, but then the solar generation is evaluated according to the area of every building. So they don't. They are different according to the roof area of every building. So it evaluates like the nominal power for the efficiency of the inverter from DC to AC, and the nominal power is the PV nominal fixed per the roof area of the building.
I was just hoping to hear a number so I can put this in context with my own home, right? I have
I can show you
kW
because I don't know if, because I looked at the data of the PV. I don't think according to the area the PV is oversized. I'm more afraid that is the the demand that is maybe too little of the building, but I can show you the data so we can have. I think it's easier if we can quantify.
Yeah, we are talking about, of course, about the ratio between the electricity demand and electricity generated by PV. That figure seems very strange.
Yeah. So I was trying different way, but let's say this is fixed to 10, and then every building have like 200
square meters
square. Yeah, but even higher, like 400. There are some buildings with 4, so they're not so like little. And then you hypothesize that all the roof of your, all the roof is occupied by the PV, which is because there is. But we can adjust also this, but there are houses with 300, 400, and what is showing.
Well, I can do the math pretty simply. If we have a nominal installation of 1,000 watts per square meter on a sunny day at 400 square meters and an overall efficiency of 20%, you would produce 80,000 watts. That's a little much, right? That's an 80 kW system for a home. That is indeed a lot. Yeah.
Yeah.
I can show you the number.
Show this.
So this is solar generation, let's say, for every building. So you see this arrive at 6 kilowatts.
And this is per hour, right? This is so kilowatt hour per hour, so kilowatts.
Yeah. I don't know if it's so crazy. We can reduce it.
It would be exactly my home.
Yeah, exactly. So I don't think it's too crazy. What is maybe more crazy is the demand. And this depend, and then the RBC is let's say going to. This is just the demand of the house of the cooling. So we need to have the shiftable loads. I don't know, like it's not, so it's around 8 kilowatt. I don't know. It doesn't seem so crazy to me, the sizing. Because this is 6, this is already like, the cooling is already, 8 under the RBC. yeah, I don't know if it's so crazy, but we can reduce it if it makes some problem.
Well, I mean, you have a certain COP assumed for the heat pump, right? And I think that was around 3, is that right?
Yeah, I think on if is it around 3, but this is evaluated directly from the environment, so I don't know how is it really calculated, but I guess correctly. So
I think Sabrina, even those numbers look. I mean, it is hot in Texas, and 10, 15 kilowatts of cooling. This sounds about right. These are also big homes, right? That would be.
Yeah.
Yeah,
That
that's
would
why
be
I'm
in
saying
US units would be 5, 6 tons of cooling. That's not unheard of for these homes.
is it
So
sorry, is it too much or is it
no.
is
So
it
we use a metric called ton of cooling is 3.4 kilowatts, and so you buy these units according to that size. So you showed me 15 kilowatts of cooling, so those would be larger units, but absolutely common in Texas.
but yes, and also like this 15, I mean, it's reached with the controller, so don't look at the 50. The blue line is the RBC, which doesn't even arrive there. So because the controller depends on how you define your controller, so there are different, but yeah, maybe this is 12. But I don't think they are so crazy according to the size of the building. But I don't know, like we can always correct if you think we need.
So in some buildings, we have solar generation that is higher than 10 kilowatts. It's correct or not?
No. The solar generation is this other axis.
Okay.
So because there are 2 axes, so
okay,
one
that axis.
is for cooling.
Okay.
So I'm showing where all the building they are arriving to 6, mostly all of them.
But I remember that for some buildings we have a very low rate of self-consumption. It's true. That buildings that you showed me.
Yeah, the district, the total district. So maybe there are.
Total district.
The total district was going like really negative. But I need to double check why it's happening. I want to check if there are some miscalculation when we evaluate the total district, because from these data doesn't seem that we have so much. I mean, it happened that you have really so what happened is that you have really high PV when there is less demand, right? So it's possible that it goes negative. So, but also the PV according to the
net demand is negative. Is that what you meant by negative?
Yeah,
net demand?
Yeah. So that you're exporting basically. Because this happen. So the PV is during the daytime, and this happened when the demand is lower. So like here is 2, and then you have 6. If happened for every building, you have, let's say, 4 kilowatts for 25 times much, like exceeding. And so this would be results in a negative.
Your outside temperatures are really high, 36 Celsius.
These are from the data.
Yeah, it's a hot summer, and why are your cooling loads offset in time? Why aren't they more coincident with high outside air temperatures? These are low mass buildings in Texas. Or are they? I have to check. Does it make sense, Sabrina? So the 37 degrees peak temperature, it seems like your cooling needs don't seem to be coincident with that, right?
Well, I don't know, like what is doing is giving. It depends also how the model of the dynamics of the temperature will respond to the cooling. So
totally, yeah. No, I'm just the driver. You have a very strong driver for cooling, and this home seems to be either by virtue of having very high set points, Yeah, where are your zone temperatures? It's a little small.
So the zone. I mean, is so all this mismatch that you see. I mean, you're expecting higher cooling when there is the peak of the temperature, maybe, but I don't know. This I don't know how much we can correct, because it also depends on how you simulate the dynamics of
Totally, and the control
building and this.
strategy and all that. Yeah. There's a lot going on.
So yeah.
Solar
So
radiation also.
yeah, exactly. So it's I mean, I was just looking. Well, I mean, as soon as we have the RBC that is inside, the band, then it's okay.
Okay.
Eva?
But yeah, I mean, we can always reduce this PV if you think it's too high. But the houses are big. So
yeah, but sorry, Sabina, but the question, maybe Eva, sorry.
No, you go off. So I had a suggestion. I wasn't because of this issue. I worked on Vermont.
Okay.
But yeah,
no,
my
but just
suggestion is
the question.
We can all work on, for example, Texas for now, for our next meeting, and then compare the results and see if the controller is the issue or the environment is the issue. Because if any group works on different climate, we cannot compare the results and we cannot find the issues. So maybe we can all work on one.
I don't think
right now.
To analyze data, I mean, we just need the RBC to see if everything makes sense. We don't need to run the controller. So
I can also work on Texas, and then we can sync the result and find the real issue here, because we want to solve the environment for everyone so they can use same environment, and there could be a benchmark. So because if anyone is working on different environment or different climate, I don't know how do we benchmark those results and controllers. This is my suggestion. I don't know.
It's a good suggestion. I think Annalise and I, we'd be happy to take a closer look at the RBC controlled Texas data and see if we see anything suspicious.
One thing to remember, the assumption of the whole roof being PV is obviously very strong, because usually it's half the roof.
Yeah.
Because otherwise you're assuming that you're exposed the whole day through the whole PV, and it's I don't know if it takes any orientation into account, and I assume it does not. It's so that most realistically would be half the roof.
Yeah, maybe we are not considering the shading effect.
But I have a question. So if the model of the PV is the same, so the underlying model of how the PV, the solar generation is created, is the same for Vermont and Texas. So before Texas was too low. I don't understand why maybe one case is correct. Let's say I didn't analyze Vermont actually. So, but if we have the same,
is January and February, there is not much for solar generation. Maybe that's the
but before, but then you're using the same model as before, right? But the Texas, same model gives Vermont low, correctly low in. So before, let's say before I made the correction on the environment life, so the same model from Vermont gave a correct, let's say, production for the Vermont, but an incorrect production for Texas, and I just wonder why.
But the way it's calculated,
check the PV for the Vermont, but
the solar generation is a PV watt simulation. So that's for the nominal power, and then you scale it up. So you can scale it too high if that's what's happening, but the underlying calculation is the same. The multiplication with how many panels you have is different in every case. So that is the only lever you really have, I think, to change that many
multiplier.
Things. Yeah.
Okay.
Which is fine, and I think you can really pick anything. It's you just play a little bit with the assumptions that you have. But one thing that you want, right? So I think this is what Alfonso mentioned. So if you do consider negative loads because you have so high solar, then you have a problem on your aggregated load, which is, I think, why we said that we should not consider negative loads. So at best, if you have negative net consumption, you should clip it at 0. So in the aggregate, it goes as 0 rather than negative.
But
right?
the targets, I when I wrote the code for the targets, I was just considering the positive side.
Yeah, but then, okay, that's correct, Zoltan. But then, when you want to implement advanced control in order to tracking that reference load profile, you have the same energy generated by PV without any kind of storage system. So we are working now just considering as a flexibility asset the thermal mass. So the problem is that we are it's quite impossible then to track that reference load profile also if you have an advanced control, because you don't have any kind of flexibility asset to reallocate that energy that is exported to the grid. And
yeah, you're saying it would help, right? That it would help to do that, right? But yeah. So, I don't have an answer. Go ahead.
I think that first we need to take care to the results with RBC control in terms of how much they are realistic. That is very important, because we start creating the cluster reference load profile from this kind of simulation. So it's very important.
But the reference is because you have the net load, your reference is messed up. That's what you mean, right?
So we build the reference load profile that then the DRL or any kind of advanced control need to track, starting from this kind of simulations. So
okay, but then technically your reference, if everything, okay, so if the reference is without control, right? That's how we agreed upon.
No, the reference is with the
RBC control.
But not for the battery, only for the temperature.
The RBC, is for the thermostatic control,
Yeah. Okay, but if you have
with PV also.
Yeah. But that means that in that time you would have no load, basically. If everybody produces net zero, then you have no load, and so you had 0, right? It's because we have an average daily profile that is a little bit higher than that, you have that higher number or the lower number, right?
Not following you, Zoltan.
No. So
maybe I'm
Sabrina,
not. Okay.
may you show the reference load profile that
Yes. Okay, I will show you weekly. So this is, so here is like the, so this is the, I mean, the net is the target is here is calculated considering only the positive part. Then there is all these are, like, let's say, surplus of energy during the day time. So we with the peak at 12, which is a lot. But it's a lot exactly because how everything is sized, right? So we were just wondering if, like, as a level of the district, maybe this is a bit too much. We can lower the PV if this is the main problem. I don't know.
And so what I meant was if your actual load, so if you clip your load, everything that's negative would be 0, right? Basically.
Not negative 100.
Yeah, exactly. It would be just 0. If you clip,
the target, the reference target was built considering 0 the energy exported.
Sorry, say that again.
Is the true?
Yeah, okay. Here the target is considering
the target is just the constant values, dashed line.
Is the dashed line considering as the like a flat given the positive part of this?
Only the positive, right?
Yeah.
Yes.
Yeah. So but you are doing already that. Yeah.
Yes. But one of my question is what's the difference if we do like this? What's the difference of doing this and just so and say to the buildings, just reduce your peak. So the real let's say profile is not only the positive, because also giving energy to the grid, I mean, also the surplus is going influencing the grid, but we are not taking into account this. So what's the objective of the exercise? Because if we want just to, let's say, having a flat profile evaluated just with the positive part, then it's, I mean, if you do, it's like telling reduce your peak, not follow a target. Like
yeah. I think, but also, I mean, the targets should be changing every day, right? So it's not the same.
Yeah. This is but this every day changes, but this is one. I think this is.
And one thing that's different sometimes is that some buildings have to increase their loads to meet that load. But yeah, Eva, do you want to say something?
Oh, I just wanted to suggest that this could actually be a prosumer problem, and we can keep the PVs the way they are. Exactly. And this could be another congestion problem, which is already like grid is facing. This would be a prosumers problem, and Vermont would be consumers. We can have two different maybe problem definition. How do we deal with that much production within household? Yeah, but that could also be a reality.
So what does that mean? That would mean that you clip, or you have to put a limit on the aggregated target load, basically, in the when it's negative.
Manage your exports. Like every building should manage their export. Like here in Netherlands, we get fined for exporting too much in certain days.
So the question, Zoltan, is if we want to track that district target that was constructed as we said, so just with positive part, what we are actually doing with the advanced control. So we are not managing the energy generated by PV in order to increase the self-sufficiency or the self-consumption. We are just trying to shed the peak.
Yeah. I mean, it's shaving the peak, but also because it's kind of like you're trying to shave the peak, but you're also trying to remain constant in your usage, right? The idea is that profile is not known, or I mean, it is known, but it's not. It's a constant value, so it's predictable, right?
Yes. Okay. If you formulate your, I mean, objective function in a way that you want to stay as much close possible to the line, yes, of course.
Because mainly because peak demand load would be only in a small window, right? Rather than throughout the whole day, basically. But I think maybe we just add a constraint here based on this, right, Alfonso? Like, so if you wanted to manage exports, then maybe you allow a maximum exports as a constraint, and that becomes another KPI, just like following the target. Like you cannot exceed.
Okay, in that case, we need to add the battery, of course, because you have no other way for.
Right. I mean, it's kind of like Sorry.
Because currently the simulation environment is set that you, of course, try to use all the energy produced by PV when you have a demand. But if you do not have any opportunity to store the energy,
and you curtail, right?
I mean, you curtail. That's it. You curtail it, and that's it, right? So, which is what I thought we would do, and then just not worry about. So that's why I'm also a little confused why we can't do that really. But we can add the problem. I mean, it's a realistic problem, right? It's a problem that we have everywhere. So maybe we pivoted it around a little bit, and then the only thing is we add a constraint to it, right? It's not an objective. It's not the flexibility. It's not the following. It's more that you curtail actively, right? And you penalize if
and curtail in a way that each home has at most a zero or at no lower than zero exports, right? Never a negative export and never an export, basically. Is that the? I thought that's a limitation we already have in the model. I thought none of the homes was able to export to the grid.
Well, I mean, you can calculate the power generation and the export. There is no mechanism that deals with it, right? So you decide what you do with that information if you have more power generation.
I don't know. Sorry, like if there is power generation, like in the negative, where these energies go. Like I know. I mean, if there.
Yeah, maybe Gregor is suggesting to size the PV panels in order to avoid any export of energy. If I understood well.
No, just curtail it. Just curtail it as a proposal. If there ever is a time when the PV panel produces more than the load of the home, then that is just shunted to, and it basically is a, if I may say, a post-processing step. But a home itself would never deliver to the grid anything, right?
Yeah. And basically, you just add a function. You say the load is max of 0 and the positive value.
So we want to model that the panels so that the home are not giving to the grid. But where is going? So, I mean, the production is there. If
it's there,
it's just theoretical. So we don't consider that energy is produced.
Okay, okay. Sorry, I was confused.
Okay, but why? Why we need we
well, it's a controllable inverter. I mean, it is an inverter.
Okay, controllable
inverter. So Sabrina, it's the power is the power electronics are such that you do not you're not forced to produce. The controllable inverter allows you to modulate for a given solar incidence. It allows you to modulate the power produced.
Okay. Yeah. Sorry, but yeah, then we need to model, I think, this in the environment, but again, just add a line.
And it's a per home. It's this max selector, right? It's the greater of 0 and the net load.
Yeah. Okay. Sorry, I was trying to find like a perspective in like how it works.
It's a controllable inverter.
Okay. Yeah, I think because I think this can be a solution because I don't think they're sized that bad. Everything
not that poorly, right?
Yeah. So we can do that if but then we should do the same.
This is one of those examples. Yeah, this is one of those examples that everybody should do. So we're all on the same page here.
Okay.
Cool.
And maybe
so we solved that.
Yeah, maybe in a week from today, maybe Sabrina and Ava and Annalise and Catherine, maybe we can see if we get more acceptable behavior after imposing that limit. How does that sound?
Yeah, we can work on that. Yeah.
I think it's a per home curtailment of a controllable smart inverter, right? Those are
but then we should do the same for Vermont because same assumption.
There's no risk there. There's no risk there.
No, just to have the same if we do different case studies or not.
We can sync because we don't have any problem in Vermont right now, but we can we can sync everything so we have one benchmark for every climate.
Okay, good. I think that sounds like an effective way, at least now, but we'll see if it does fix the problem.
Okay, so with that, I think we're coming to an end. But yeah, just the until our next meeting, hopefully more people can try. Oh, Shahab.
Maybe Shahab has a question.
Yeah.
Yes, I have a question for those who want to start working on this common exercise and are joining maybe first time today. Can you please describe, do they need to do this common exercise individually or in group, or how, what is the procedure? Thank you.
I think you do it however you want. To be honest, if a group of people want to do it as one, you can do it together. I don't think there is a limitation on the teams. I think what you see is that a lot of people are working, but I think still Sabrina will submit her own solution and Ava will submit her own solution and Elise will work on her own solution. But at the same time, they're exchanging the information on making sure that everybody's working on the same thing. Does that make sense, Job?
Yes, thank you. And about this curtailment problem per houses, this is common in Denmark when there are periods with a lot of wind where they turn off some of the wind turbines, so it's not strange.
But that's on the grid, not on the individual homes, right?
Exactly. That's on a bigger scale.
Okay. Cool. So I would encourage everybody to get started, and then feel free to type in the Slack easily. Everybody's nice there, so no need to be shy. And if you have an issue getting started or stuck somewhere, people will respond. Gregor, for last words?
No, I was just looking at some of the Slack comments, and you're saying people are nice. Yes, they are very nice. Yeah, a lot of smileys, I see. A lot of smileys.
Yeah, in your best smiley game.
And Sabrina and Ava and Catherine and Annalise, this change, is this something you want to report through Slack, or do we want to get together next Friday? Promise my alarm clock will work.
Either or is good for me.
Yeah, it's just because, it's odd behavior right now. So why don't we briefly check in and just as a small group and see how things are going. How does that sound?
Yes.
Yeah.
Yes.
Okay.
That's a good idea.
I'll send out an invitation. Okay, for make it 7:30 a.m. here. So okay, just for a brief check-in. Super. Okay. Well, we have a few motivated participants, so let's hope that this leads to some activity. We just in terms of our next official meeting, that'll be on the 13th of February. Okay, February 13th, just to have a heads up on that. Good. Thank you, everyone. With that, I'll say have a good rest of Friday, and thanks for all your hard work, especially the team that's been doing all the preparatory work. It's really appreciated. And we'll in that smaller group, we'll meet next Friday. Okay. Bye-bye.
Thank you.
Bye.
Thank you. Thanks, everyone.
Bye, everyone.